Hi everyone, today I am starting units and dimensions. Starting with units. What is a unit? Um, it is a means by which we can measure a physical quantity. Means to measure a physical quantity. For example, we have 5 meter. 5 is the magnitude, m is the unit. Then 5 times 1 unit, which is 5 meter. It's the representation of the unit. Coming up to the SI system of units. What is SI system of unit? It's the main system which is accepted by everywhere in the world. For SI system, some units, for 7 fundamental units are there. For length, it is meter. For mass, it is mass. It is kilogram. For time, it is second. For electric current I, it is ampere. A. For thermodynamic temperature, that is temperature basically. Temperature is capital T, this is small t. Time is small t. And this is Kelvin. That is a very basic thing we are. Amount of substance, it's mole. Mole. Amount of substance, amount. We will study this more in chemistry. Luminous intensity, L is candela. CD. You can remember you can know the definition if you want. It's present in Google easily. You can access from there. I am starting with dimensions. What is dimensions? Dimension is the physical quantity. Dimension of a physical quantity, the powers to which a fundamental quantities can be raised to represent the given physical quantity. For example, let me take the dimension of density. Density is there in my question. Yes, density. I am solving first question of today, density in this part only. Density is dimension D. What is it? We must express it first as a part of fundamental quantity, mass per unit volume, mass per unit length cube. It comes to a mass per unit length cube. Yes, unit will be length cube, by the way. That's the thing we need to know exactly in dimensions. It is dimension is represented within square brackets. It will be what is M. We have to write capital M for mass, L for length, T for time, A for electric current, and so on. Hence here its power is 1 and L power is -3. This dimension. You understand what is the dimension? Where is it? D is equal to m by p. We must find the dimension like this. This is the process. For units like temperature, mole, K, mole, CD, these things are used in dimensional analysis. With this much knowledge, I think we may proceed to the question. This is the question. We must find the dimension of density, velocity, acceleration, momentum, force, work or energy, power, and pressure. Try it out. I am starting with the solution. You must try the answer by pausing the video. Density we have already done. It's m L to the power -3. right? Velocity, what is velocity? Length by time, right? What is it? Length by time. Length is L, time is t to the power minus 1, t to the power minus 1, right? L t to the power minus 1. What is acceleration? Change in velocity, change in velocity with respect to time. Change in velocity, velocity is the dimension is this, and we again divide it by time, then acceleration will be L t to the power minus 2. Minus 2. What is now momentum? Momentum is mass into velocity, mv. Mass is m, velocity is L t to the power minus 1. ml t to the power minus 1. As simple as that. What is force now? Force is mass into acceleration. Mass is m, acceleration is L to the power minus 2, then m L t to the power minus 2 minus. Now work or energy. What is work or energy? Force into displacement means length. Then it will come to be force into length is m L square t to the power minus 2. Right? Nice. Moving on to power. What is power? Work per unit time. Right? I am writing it here only. Work per unit time, then it will come to be m L square t to the power minus 3. T to the power minus 3. This is the dimension. Don't forget to write the square bracket system representation only. Now pressure. Pressure, what is pressure? Force per unit area. Force per unit area, right? What is force? M, where I've written force this. ml to the power minus 2, pressure will be divided by L square m L to the power minus 1 t to the power minus 2. Moving on to the next slide. This is again some dimensional analysis questions. First, let me give you the formula. Surface tension T is F by L. We will all learn these formulas in different chapters. We are only doing the dimension analysis. What is gravitational formula? Universal F is equal to G m1 m2 by r square. G m1 m2 by r square. R square. What is impulse I? Impulse is J. Sorry, impulse is J. Impulse is represented by J because I is already current. Now this is F into T into T. Torque is tau, which is F into L. F into L. Now you may try the question. By pausing the video, I am moving on to the solution. First, let's do surface tension. What was the forces dimension analysis we will use the most? I am writing force dimension analysis here once for convenience. Well, yes, here. Okay. Now F. What is the dimension of F? ml t to the power minus 2. ml t to the power ml t to the power minus 2, right? Now F by L, it will be m t to the power minus 2. Universal gravitational constant. We must find out what is first g. We must find g here. This is the thing you must know. F into L square into m by 2 m square again means force, this force into length square by mass square. What comes to be equals to that? First, force by mass square. Mass is force, power is 1 divided by m square, then power will be 1 minus 2, which is minus 1, m to the power minus 1. Length, there is already 1 here and we are adding 2, 3. Time will remain as it is. This is the dimension of universal gravitational constant g. Moving on to impulse. Impulse is force into time, nothing, multiply by time, ml t to the power minus 1 per minus 1, and then there is torque. Torque is force into length, then it will be m L square t to the power minus 2, right? Where have we here this ml t m square L square t to the power minus 2? Yes, we have edited work. Dimension of work and dimension of torque are same. Moving on to the next slide, this is the next topic. Uses of dimension, we will cover the first use today only. Next uses we will cover in the next videos. Conversion of units. Based on the fact that the product of the numerical value and the corresponding unit is constant, right? Then we can find, we must know some conversions, then we can easily find the we can convert SI system to CGS system, right? It's a very important use. You must use the we have very good applications of this here. Suppose we have a fundamental quantity which has A in mass, power of mass is A, m to the power A. We have a physical quantity L to the power B, and time to the power C. Sorry, this. Yes, we have that m to the power A, L to the power B, T to the power C, m1 to the power A, L1 to the power B, T1 to the power C. And if we multiply it by n1, then another value n2 will be equal to that changed. Like if this is in kg, we will convert into g. Then if it will be L is in meter, we convert into centimeter. Then if time is in seconds, we convert it to hour. Then this will change, but product will remain same. This is the concept behind the conversion of units. Here n1 and n2 are the numerical value of two systems of units respectively. This equation, we can convert the numerical value of physical quantity from one system to other system, right? This is the next question, convert G to CGS system of units. First, let me write the system value in SI system. It's 6.67 into 10 to the power minus 11. I'm only writing the magnitude because if I write the unit, you can easily know the answer. So I will not write the unit, you must solve it yourself. Solve the question by pausing the video and moving on to the solution. What is the dimension of G? M. What is it? m to the power minus 1, you must remember this, m to the power minus 1 L cube t to the power minus 2, right? Yes, t to the power minus 2. Convert each and everything. This is SI. This is SI. In SI, mass is in kg. We convert it to mass is in kg. We convert it to gram, right? But its mass inverse, then it will come to be 10 to the power 3. If we convert, the product will be 10 to the power 3. Length is meter. 1 meter is equal to 100 centimeter. 1 meter is equal to 100 centimeter, then it will be 10 to the power 6, right? You must understand what I am trying to say. I convert this kg to g. 1 kg is equal to 1000 gram. Hence I write 1000 here because inverse does not have any effect. Sorry, if I told inverse. Inverse does not have any. 1 by kg and 1 by g will be same thing. Means 1000 will be the quotient when 1 by kg is divided by 1 by g. Then this is not the thing to be worried of. This will be, if we convert kg to gram, kg inverse to gram inverse, there will be also be 10 cube only. Second to second, nothing to change. Now, if we convert this to CGS system, multiply this by 10 cube and 10 to the power 6, which is 10 to the power 9. Multiplying this with 10 to the power 9, we get 6.67. 6.67 into 10 to the power minus 2. This is the answer of the question. We will cover the next part of this chapter in the next video. I am ending this video here only. Thank you.